Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome one and all to another bumper episode of K-Way Mathematics. I'm your host and presenter, Mohammed Kota from the K-Way Mathematics Institute here in Johannesburg. As per usual, on our daily slot, we're now preparing the grade 11s and 12s for the final examinations in 2015. We stopped yesterday, or we stopped in our last episode with calculus. We're now going to go, we ended off with differentiation. So just to quickly recap what we did in our last episode, we started with first principles in calculus. We then did the derivative. We did differentiation. We did limits. We're now going on to finding the equation of a tangent to a point, the cubic graph, and optimization. So like we said the last time, grade 11s, you don't need to know any of this. But if you are paying attention, you want to up your skill, no problem. Pay attention and get with the program. We're now going to start with finding the equation of a tangent at a point. So the question in the exam would state, if f of x is equal to 3x squared minus 2x, find the equation of the tangent to f of x at x equal 4. Question like this in the exam, 5 marks. Answer. Now, what we need to do here, boys and girls, is that we need to understand what is happening. We have a parabola, right? 3x squared minus 2x is a parabola. So just to give you a rough indication as to what we're talking about, there's a parabola that's passing that looks like that. That's just a very rough sketch. At the point x equal 4, there is a tangent passing that. At the point x equal 4. They want the equation of this tangent. Now we know that the tangent is a straight line. And the equation of a straight line is given by y is equal to mx plus c. Okay? What do we need in order to get, for y is equal to mx plus c, y is equal to mx plus c, what are the two major components that we would require in order to get this equation? We'd need a m value, which is a gradient, and we'd need a c value, which is your y-intercept. Those are the two crucial components that we would require in order to get that equation. So let's get started on how to. This here is just to give you an illustration as to what is going on in the question. They say, if f of x is equal to 3x squared minus 2x, find the equation of the tangent to f of x at x equal 4. Now, step number 1, I'm going to give you a copy and paste process. Let's start with step number 1. We got an x. We need a y. We don't have a y. Now, if the x and y was given, you wouldn't need to do step number 1. But because only x is given and we need to find y, the first step that we're going to do is take this x value, plug it into here for every x to get our corresponding y. So now we're going to say f of 4. f of 4 is equal to 3 into, for every x, I'm now going to substitute 4. 3 into 4 squared minus 2 into 4. This is equal to 4 squared is 16. 16 times 3 is 48. Minus 2 times 4 is 8. 48 minus 8 is 40. That means my coordinates at the point where x is equal to 4, y is equal to 40. Now we've got an x and y. Again, I'm going to repeat. If the x and y was given, we wouldn't need to do first step. But because only x is given, we substitute x to get our corresponding y. Okay. Now we need to find the gradient, and I told you guys from the start that the word calculus means gradient. So we want to find out the general gradient on that parabola first. So we now, what do we use for general gradient? We're now going to use f dash x. So f dash x is equal to, we're finding the derivative of the original to give us the general gradient. This here is going to give us the general gradient. So the general gradient on f of x is going to be, we're going to be using derivative 2 times 3, 6x minus 2. 6x minus 2. So therefore, the m of your tangent, your specific gradient, right? Your specific gradient is going to be, so we can write the m of the tangent, or we can say f dash 4. Doesn't make a difference. So the gradient of your tangent is going to be 6 into, we've got an x value here which is 4, 6 into 4 minus 2, 6 times 4 is 24, 24 minus 2 is 22. So now we've got the m value. We've got the m value. We now need to get the c. Remember, from y is equal to mx plus c, y is equal to mx plus c, we now got the m value. We now need the c. So what did we do? We found the derivative. Step number 1, find the derivative. Step number 2, take the x value, plug it into the derivative. You now get the exact gradient. That means you now have 22x plus c. So we've got our m value. We're only short of c. Now we want the equation of the tangent. Therefore, the equation of your tangent will be given by, now you know when one pair of coordinates is given and the gradient, we can go into the formula grade 12, y minus y1 is equal to m into x minus x1. Right? And then we remove the brackets and we get it into the form y is equal to mx plus c. So y minus y1, we're going to be using the point 4 and 40. So y minus 40 is equal to m, which we got 22, into x minus 4. Remove the brackets. Y minus 40 is equal to 22x minus 22 times 4 is 88. So y is equal to 22x minus 88 plus 40 will give me minus 48, and there we go. That is your final answer. That is the equation of your tangent. Y is equal to 22x minus 48. Okay, so step number 1, we substituted x in here to get our corresponding y because we need x and y. We then find, so we can call this, let's highlight that, step number 1. Step number 2, the general gradient. How do we find general gradient? We use the derivative, yes. Number 3, we find the specific gradient. From the derivative, we substitute the x in there. We get the exact gradient of the tangent. Step number 4, we now go into the equation of the tangent. It's done in 4 steps. Boys and girls, a question like this is worth 5 to 6 marks in the exams. Please make sure you know this.